right, good morning, good afternoon. We're going to take a look at Chapter 11, Section 4, Day 1, area of regular polygons and composite figures. So we're going to break this up into two different lessons. Regular polygons, we're simply talking about pentagons, octagons, something that have all the sides are the same and then all the angles are the same as well. Again, I'm going to leave this warm up to you as extra practice. If you'd like to do it, you can check your answers on Haiku using the Note Packet answer key. So today our problems are going to get a little bit more involved. So here are just some simple steps of what we can do. Now I'm going to start with this hexagon down below. We're going to split the hexagon basically into triangles. So you'll see that this hexagon is really just 6 triangles added together. So what we're going to do is we're going to find the area of one triangle, and then in this case multiply it by 6, or however many triangles we have. So first I want you to draw the figure out on your piece of paper if you, when you're working on your assignment, and make sure you label any information you know. I want you to simply draw in the triangle. You can draw in one or all of them. Just one is necessary. You need to find the central angle. Now this is the angle we need to find. And how do we find that? We're going to find it by dividing 360 by the number of triangles we have. So in this case, we would take 360 degrees and divide it by the number of triangles we have. That's going to give us that central angle. Okay? The next thing you're going to do, well, remember when we need to find the area of a triangle, we need to know the base and we need to know the height. So here's the base of our triangle and here's the height of our triangle. You might have to use our special right triangle because we have a right triangle here. You might have to use those tools. So we have Pythagorean theorem, we have trig, we have special right triangles to find the height of this triangle. Now a different word for height is apothum. So this length from the center to the middle of the base is called the height, or is called the apothum, also known as the height of the triangle. We might also have to use those to find the base of the triangle as well. After you have the information you need, you're going to find the area of one triangle and then multiply it by how many triangles there are. And remember, to find the area of a triangle is 1/2 base times height. Okay? There is another method. I'm not going to go into too much detail in it, but if your book does use it, it's area equals 1/2 your apothum times your perimeter of the entire shape. So let's take a look at example number 1. Let's see, I think I missed one. No, let's see. Oh, we're just identifying, sorry. Identify the center, the radius, the apothum. Remember, that's the same thing as the height of a triangle, and the central angle. And then we're going to find the measure of the central angle. So the center right here is x. The radius, you can go from x to q, or you could go from x to r. You cannot go x to n because it doesn't go all the way to the edge of the circle. The apothum is going to be the height of our triangle. So in this case, x to n is the apothum. And our central angle is going to be this angle right here. Angle RXQ. All right. Knowing those parts of the figure are very important in solving these problems. So here we have the top of a table. It's a regular hexagon, so we know all sides are the same. Each side length is 3. So we have this side is 3 feet, and the apothem, which is drawn in here, is 1.7 feet. What is the area to the nearest 2? So it's important that we label our information. So we're going to find the area of one triangle first. So 1/2, the base of the triangle is 3, the height is 1.7. When we multiply that out, and sometimes I use subscripts, it just shows that the area of the triangle is 2.55. So that's the area of that triangle. We have 6 of them, so the total area is going to be that number times 6, which will give us about 15.3 feet squared when we round that. So that's the total area. Let's take a look at 2 more problems. These ones are missing some information, so we have to use some previous knowledge to figure this out. Now, if we look, we're only given the base here, which is 5. So our goal is to find the area of a triangle, 1/2 base times height. Our base is 5. However, we do not know what our height is right here. So before we move any further, we're going to find our central angle. So our central angle is going to be 360 degrees all the way around, and divided by 6, because we have 6 triangles or 6 sides. So we should get 60 degrees for our central angle. Now you'll notice that our triangle here, this entire angle is 60. It is split in half. So this part of the angle right here is only 30 degrees. It's half of the 60. This whole length is 5, so this half is actually 2.5 or 2.5. So now we have that triangle, and it might help to draw it out separately. So we have 30 degrees, we have 2.5 here, and we need to figure out what the height of that triangle is. So if you're good with your 30, 60, 90, you'll see that this is our short side here. This is going to be our short side times square root of 3. Now, if you didn't like that, you could use trig. So this right here is our height. Now what we can do is we can substitute that height in for, I'm not going to have enough room there, in for our height of our triangle. Okay, so multiply that through. The area of the triangle is about 10.83. So that is that triangle here. Now notice when we substituted in, we used 5, the entire length from Q to R. All right, so that's the area of one triangle. We have 6 triangles, so we're going to multiply that by 6. So our total area should be about 65 meters squared. Okay, and again, you'll see some of these problems are a little bit longer, and they rely a lot on some previous knowledge that we have. I'm going to erase some of this to give me a little bit more room for part B. So here we are given the length from C to B. So when we find the area of a triangle, we know we need 1/2 our base times our height. We don't have either pieces of information here. So sometimes people get stuck. Remember, there is some hidden information, and that's our central angle. So find your central angle first. So 360 divided by, in this case, we have 5 sides. It's a pentagon. So our central angle is going to be 72 degrees. So this is 72 degrees. Okay? Now, if we look at our triangle, it's divided in half. So half of 72 is going to be 36 degrees. So this angle is 36 degrees. I'm going to again draw that triangle out on the side, a little bit less complicated. So we have 36 for our central angle. We have 9 for this side, or the hypotenuse. We need to figure out, I'll just use A here and B here. We need to figure out what A and B are. So because we don't have a special right triangle, we have 36 degrees, we have to use trig here. So I'm going to label our sides, opposite, adjacent, hypotenuse. So if I want to find side A first, the opposite over hypotenuse. Opposite over hypotenuse would be sine. So sine of 36 equals opposite, which we labeled as A, over our hypotenuse, which is 9. Multiply each side by 9, or put this over 1 across, multiply. Either way, A is going to be 9 sine of 36, which is about 5.29. So this side is about 5.29. Now, why you have that number in your calculator, this part is 5.29, just hit times 2, so that gives us the entire length of the base. So if you hit times 2, you should get 10.58 for our base of that triangle. All right, so let's backtrack a little bit. So we have this side. Now we need to find the height of that triangle. So we have the adjacent over hypotenuse. That's going to be cosine. So we're going to use cosine of 36 equals our adjacent side, which we labeled B, over the hypotenuse, which is 9. Multiply each side by 9, or put it over 1 and cross multiply. You should have 9 cosine 36, which if you put in your calculator, you get about 7.28. We don't want to round too much initially. Really, we should wait for the rounding at the end. So try to keep these numbers in your calculator as much as possible. All right, so our height of our triangle, what we just found, is 7.28. Now we should have all the necessary information to find the area of a triangle. So, just going to give myself a little bit more space here. 1/2. The base of the triangle is this entire length. That's that 10.58. The height was at 7.28. Multiply that all together. So the area of one triangle is going to be 38.5112. And again, you don't want to round too much right away. That's the area of one triangle. We're going to take that and multiply it by 5 in this case because we have 5 triangles. So our total area should be 192.6 centimeters squared. And you want to wait to round until this step right here. Okay, so you'll see that these problems are going to be a little bit more involved and take a little bit more time. Work on your assignment. Please, please, please draw these diagrams out. If you get stuck, make sure you found your central angle. And if you have questions, please, please, please ask your teacher. Okay? Have a great day. It's a perfect day to be, a better you.